which means we have to kind of see what misconceptions there are and then improve. So the first set of identities I gave you were one of the least demanding, but anything new is new. So this is no different than a regular trinomial. The A would be 3, the B would be 4, the C would be 1 on top. Here the A would be 1, the B would be 2, the C would be 1. So just factoring it like a trinomial. And what happens is we're able to simplify one of the factors on top and bottom, and we get something a lot simpler to deal with. Okay, and then 19, we could just go ahead and change the cosecant to 1 over sine. And then we now can combine and we get the equivalent of the cotangent. Okay, now this one, anytime you square something, it's always going to be positive. So this is no different than the tangent of the positive angle. If that wasn't squared, then we'd have to interpret that a little bit better. So remember, the tangent is an odd function. If you change the sign of the angle, then the function changes its sign. That's because rotating in the positive direction for the tangent is different than rotating the negative direction, because you get a negative in the fourth quadrant for the tangent. But since it was square, that's irrelevant. So anyway, once we do that, then we get the trig identity, 1 plus tangent squared, which is the same as the secant squared. Okay, and again, try to focus only on one side if at all possible. If you get stuck, then maybe simplify the other side, and that can help. All right, so that's what I'm doing here. The complicated side is definitely the left side. So I went ahead and changed everything to sine and cosine. And then once I multiplied the cosine, that simplified the first fraction, whereas the second fraction, we get a cosine squared on top. And then at this step, you might have been confused. So here's where the issues with fractions that linger come in. Not thinking that you need to get a common denominator. Sometimes that's an issue because of the issue with fractions. So that's what I'm doing here, getting a common denominator. And once we did that, that wound up with sine squared plus cosine squared on top. And that becomes 1 over sine. 3. Okay, and then here, again, I'm only working on the left side because that was the more complicated. Here I changed everything to sine and cosine, which enables us to simplify these two to 1. Well, that's a trig identity. 1 minus cosine squared is sine squared, so therefore we've proven that identity. Okay, then here, multiplying these binomials, if you need a visual, they're conjugates, right? So we're going to get a difference of 2 squares, secant squared minus 1. Well, that is another trig identity, the Pythagorean identity. That is the same as tangent squared, and so we're done. Okay, and then here, to me, multiplying these was the better way to go. Now, these are also conjugates. So again, if you want to see a visual, I substituted S and T for secant tangent just to abbreviate. And so then we get this. And now I went ahead and replaced the secant squared with the Pythagorean identity, 1 plus tangent squared. And that enabled the simplification to be reduced to 1 minus 0, which is also 1. Okay, again, similar thing here, turning the tangent to sine and cosine. After you multiply, you get the trig identity, and then that's the same as 1. All right, and then here it's a little more involved because you actually had to do some of these calculations. So I went ahead and used the area model. It makes it a little more visual. Okay, so over here we're going to get sine squared plus cosine squared plus 2 sine cosine. Same thing here, except instead of positive 2 sine cosine, it's minus 2 sine cosine. So that means those are eliminated. It's positive and negative. And then we get sine squared plus cosine squared plus sine squared plus cosine squared. And 1 plus 1 is 2. Okay, and then this one was a little more involved because it might have been easier to try to get the left side simplified and then the right side simplified by factoring out. So I factored out a secant squared on the right. I factored out a tan squared on the left. Then we get the Pythagorean identities, which can replace. And then we've shown that one side is equal to the other. Now, if you're required to only work on one side, then what you can do, if you want to continue it on the left side, just go back in the direction of the right side. So now that's why I pointed this arrow up. So then the next step after this, we could use what we had written over here on the right side. And then we could show that the left side can be completely turned into the right side. So if you have to work on only one side, you can work on both first, and that enables you to just go to the other side and write the steps in reverse direction, which is what I'm doing here. So that if you have to do that, that's how you can handle that situation. Okay, and then here, I decided to work on the left side first, because I didn't want to mess with this fraction if necessary. So I changed to sine and cosine, combined them. And now this is where this gets tricky. So if you're not sure what to do, you want to try to get the left side equal to the right side. And so on the right side, the bottom is 1 plus sine. So I thought, okay, well, let's multiply top and bottom, the left side by 1 plus sine, because that'll get us something that we want to be on the bottom. And so that's why I chose this step. Now notice on top, that gives us conjugates. And since 1 minus sine squared is cosine squared, we have this. And now after simplification, we wind up with the same value on the right side. So again, I decided to multiply top and bottom, the left side by 1 plus sine, because that's what I saw on the right side. So we wanted that denominator. That's how I made that decision. And you see, and it turned to work out. So that was a good idea. Okay, now if you had trouble with 39, you'll see, I think was a lot easier than you thought. So I went ahead and regrouped. I changed the 4 into 3 plus 1. And so that enabled us to have 3 sine squared, 3 cosine squared. If we factor out the 3, we get the Pythagorean identity, 3 plus times 1. And so that's the same thing. So I just rearranged the 4 cosine squared into cosine squared plus 3 cosine squared. Okay, and then 41. Now 41, the first time I did it is I got a common denominator, and then I got to here and I'm like, that looks yucky. You can actually go further than what I did here, but I stopped because I just felt there might have been an easier way. What you could do is multiply top and bottom by the conjugate of the denominator, right? And that actually did work out, and I kind of showed that here. Originally, I goofed up because I forgot to put cosine squared here. I forgot that was cosine squared. But you could multiply top and bottom by 1 minus sine, and if you want to see, that actually works out. It just takes a little longer. But if you get to a point where it looks more confusing, probably a good idea to stop and then try another way. Okay, so I went up here and I thought, okay, what else can I do? Well, maybe we could use the Pythagorean identity and get everything in terms of sine. That way we have one trig function. So that's what I did next. And then I looked at that. I'm like, well, wait, that's a difference of 2 squares, which would have come to the multiplication of these 2 conjugates. So notice I'm kind of reverse factoring. And then, oh, well, that gets rid of this 1 plus sine. And then now we have a lot easier way. And I was really excited. So